Welcome back to the course entitled Symmetry, Stereochemistry and Applications. So, in the previous lectures, we were discussing about diastereomerism in the cyclic systems. In this current lecture, we will discuss about the diastereomerism in pi systems. So, the pi systems include compounds containing C double bond C, C double bond N and N double bond N type of bonds which are stable and rigid, which there is a restriction in bond rotation. This restriction gives rigidity, and rigidity gives rise to cis trans isomerism, which is also called diastereomerism in So, we are trying to work on the molecules which has CC double bond, and you have groups on one side of the double bond or the opposite side of the double bond. When they are on the same side, we call it as cis, and when the groups are on the opposite side, we call them as trans. The common examples are cis 2-butene, and trans 2-butene. These two compounds differ in their melting points. Cis 2-butene melts at minus 138.9 degree centigrade, whereas the trans 2-butene melts at minus 105.6 degree centigrade. Similarly, the boiling point of cis 2-butene is 3.7 degree centigrade, whereas the boiling point of trans isomer is about 1 degree centigrade. So, this difference of physical property can be utilized to identify these two isomers cis and trans 2-butene. From our discussion on nomenclature, we had got an idea of E and Z notation of double bonded compounds. So, we would like to recall that here as well. Suppose we have a compound which is this one, and I have another compound which is this one. So, what would be the stereochemistry or stereochemical designation of these two compounds? So, what we learned in our nomenclature lectures is that we then need to prioritize the groups which are connected to the double bond, and then based on those priority groups, whether they are on the same side or different side, we name them as E and Z. So, here in this case the C2H5 group has higher priority over the methyl group. Here also C2H5 has higher priority over methyl group. So, here the two high priority groups are on the same side. So, we call this as a Z isomer, while here the high priority groups on the other opposite side of the double bond, therefore, we call this as E isomer. We will leave these descriptors in this lecture in the following examples. Suppose if I have these compounds, they are non superimposable mirror images. On the other hand, the trans isomer, the cis isomer, we should draw are also non superimposable mirror images, and this isomer which is E and this is Z, they represent a pair of diastereomers. We may encounter in our studies a number of compounds which may contain more than one double bond in that compound. So, when you have multiple double bonds, maybe 2 or 3 double bonds, we should then try to start identifying all possible stereoisomers of that compound. So, when we have at least 2 double bonds, let us see with one example. We have one isomer of 1, 2, 3, 4, 5, 6. So, this is 2,4 hexadiene, but this name is incomplete. Why? Because we have not mentioned the stereochemistry of the double bonds between 2 and 3 and 4 and 5 in terms of E and Z. So, what should be the Ez notation of this molecule? The first one, where the methyl group and the larger group are in opposition, so it should be E, Again here the methyl group number 6 and the larger group are in opposite side. So, that also should be E. So, the name of this compound, the correct name of this compound should be 2E 4E hexadiene. Let us see what are the other possible isomers of this compound. So, here this is E and this is Z, because now here the two groups which are higher priority on the same side. So, this should be numbered and then you can name them, and the third possibility is this one. Where this bond is Z and this group is E. So, we have 1, 2 and 3 isomers that are possible for this compound. Now, we will try to see what happens when we have two different groups at two ends of a double bonded of a diene. Suppose we have a methyl group here, so this is 1, this is 2, this is the third one, and this is the fourth one. So, now if we try to identify these compounds with the EZ notation, if you see the molecule, we always should number from the left hand side, so that the double bonds gets the lowest priority. So, this is heptadiene, and in the first case this is 2E 4E. In the second case, this is E, but that is Z. So, it should be 2E 4Z. In the third case, this is Z and that is E. So, it should be 2Z 4E, and in the fourth case, this should be Z and that also should be Z. So, it should be 2Z 4Z. So, here we have 4 isomers and they are diastereomers, and they can be designated with appropriate EZ nomenclatures, as we have learned in our previous class of IUPAC nomenclature. So, I will give you one homework to find out what are the possible isomers of these compounds and identify them appropriately with their corresponding Ez notations. So, the name of this compound should be 1, 2, 3, 4, 5, 6. So, the name of the compound should be hexa 2,4 dienoic acid. So, here that E should be dropped. So, it should be dienoic acid, but you would have to identify the correct stereochemistry at 2 and 4 positions and draw all the isomers yourself. Let us see what happens when we try to combine the RS notations with the Ez designations. So, when we are saying that there should be RS notation, that means the compound must contain a chiral center. So, let us take one such example. So, that is the chiral center. So, if we try to draw this molecule now, we should draw it like this. Sorry. So, this is suppose the R isomer, and this R isomer has two most prior groups in opposite side. So, this is E. So, the name should have the stereochemical designation R for the chiral center and E for the double bond. On the other hand, this compound, which is having the methyl group this side, keeping the stereochemistry of the chiral center unchanged, should have R and Z. I would like you to identify the names of these compounds, and it is possible to have the S configuration of the chiral center. So, in that condition you should draw the molecule like this. This will be S and E, whereas the other one should be S and Z. So, these compounds you should try to name them with the corresponding R and E descriptions. number the atoms appropriately and try to write down the name of this compound yourself. Now, let us try to take one more example where you will have two chiral centers and both the chiral centers, chiral carbons are present on the same carbon atom of the double bond. So, this compound has this chiral center as S and this chiral center has the R designation, and when we try to name them, the chiral center with R designation gets priority over S. Therefore, the higher priority group is here and here. So, this compound has the double bond in the Z description, whereas in case of the other compound, this S and R, the higher priority R and the methyl group are in opposite the side of the double bond. So, the double bond has the Z notation and the compound has appropriate R and S designations at the chiral centers. So, this is how you can draw several stereoisomers of the compounds which simultaneously contain a chiral center and also contains one or more double bonds. So, this you should practice from some standard textbook, draw the molecules and identify those chiral centers by R and S, which we have already done in some of the previous lectures. So, I do not want to continue discussing about how to identify R and S in this lecture. From here we will start our next lecture. Thank you.